question from the production of X-rays. থাকলে আমাকে বলতে পারো। X-ray generation. Okay, so what I'll do is I'll ask you questions to see how much you can recall. This is generation of X-rays. Can anyone tell me, for X-rays to be generated, what is the most fundamental requirement? No. Fundamental requirement মানে হচ্ছিল for X-rays to be generated, what fundamental principle is used? Okay, close. আমার কোয়েশ্চনটা আবার বলি, X-ray generation what was the most crucial part of the process? Almost there. Yes, it's stopping very fast moving electrons. That's the main requirement. Now, to stop the fast moving electrons, what do you need? A dense metal. But the main requirement is there are fast moving electrons coming in, and as these electrons are coming in, you want to slow them down rapidly. And the rapid slowdown is only possible using what? A very dense metal, right? So when you have these fast moving electrons moving in and they slow down very rapidly, what happens is that they lose the energy due to deceleration, right? Because you're losing Ke. That happens to come out in the form of what? X-rays. Now, it turns out that 99.9% of the electrons will actually go and collide with the metal, and they don't completely stop before. But some electrons will stop before they reach the actual impact because of the repulsion. So if it stops like that, doesn't it mean that there must be some energy loss? In what form is that energy loss? In the form of waves here, X-rays. It's a bit more complicated than this. This is the most advanced you need to know for your A-levels. There's actually something else to do here with excitation, de-excitation of lead atoms. It used to be there before. So you'll find in the old papers, এরকম একটা graph থাকতো, like this. So you'll find that the graph has these peaks here like that. So এরকম একটা graph আসতো, 4-5টা peak পাওয়া যেত. And the question used to be like, what are the peaks for? It's to do with the energy levels of lead. ওটা আমাদের নাই আর। আচ্ছা, so we only have the idea that with very fast moving electrons, when they're slowed by a dense metal, they release the energy in the form of X-rays. Now, this is the design of it. So you have like a process of producing those electrons. How are you producing those electrons? Using something called filament, and the process that produces the electrons is called thermionic emission. The filament heats up to a very high temperature, and then it starts to release the electrons, and as the electrons are moving out, we use a positive terminal to accelerate the electrons, and eventually the electrons will gain a lot of velocity and Ke, and by the time they reach the surface, they're made to come to a sudden stop. And what they do is they release their energy in the form of X-rays. We have a plate here that's at an angle so that the X-rays can be directed somewhere else. Otherwise, if you had a flat surface here, the X-rays will go back to the machine, right? So there's an angle out there. And as I told you that 99% of the energy is taken in by that component there, it overheats, right? So to prevent the overheating, we have two mechanisms out there. There's continuously like a fluid running around this thing, taking away what from it? Heat. It's called the circulating fluid. And the other one is that the thing is spinning. And because it's spinning, what happens is that no one place is getting the heat for too long, so it doesn't overheat. And by doing that, you're generating your X-rays. Now, there's a math involved here. Math দেখে রাখি আজকে। ওটা হচ্ছে finding the lambda of the X-rays, like wavelength of the X-rays কেমনে বের করতে পারবা। এটা হচ্ছে it's not very popular, but it's there in your syllabus, so দেখায় রাখি. So first of all, where does the wavelength come from? The energy of the X-ray. The X-ray's energy is based on what formula? Can you remind me of a formula for energy of a wave? H lambda. Hc by lambda equals to hf or hc by lambda. Now that E is the energy of that X-ray being released, right? If I assume all my electrons' energy is given off as X-rays, right? All that energy, what energy is that? K, and it's given out in what form? X-ray. Eta tomra derive korba. Can you tell me equal to hf hobe by hc by lambda? But what is this going to be on the other side? K, right? What should Ke formula be? Half m v square. Half m যেটা mass কিসের হবে? Whose mass? Electrons, right? Times the velocity of the electron square equals to hc by lambda. Now comes the important question. How do you find the kinetic energy of an electron moving? Yes. Stopping voltage. Yeah, stopping voltage was one of the ways we did earlier, right? Not here. HF equals to 5 plus half mv square. That's through photoelectric effect. Yes. So there was this formula you had in your O levels. The energy that an electron carries in a circuit, E equals to QV. Okay, and this V is a potential difference out there. So this K that you have here, this K is provided by what? The filament, provided by the filament. Because filament থেকে যে energy টা আসছে. So by the way, we are making an assumption here. What is that assumption once again? Yeah, that the electron that's been released came from where? The surface, right? But reality of the electrons come from inner layers, so they will have less energy. So here you can say QV is equal to hc by lambda. And using this equation, you can actually find out the wavelength of your X-ray out there. So you'll find that তোমার যে ভোল্টেজটা দরকার to generate X-ray, right? Is it a random voltage or it needs to be a particular voltage? A particular voltage, right? And if I want X-rays, so let's try this out. Example, okay? How much voltage do I need to generate X-rays? Let's see. Can you give me an estimate for the wavelength of an X-ray? You had this in your syllabus, the wavelength of an X-ray. A micrometer. 1 nanometer. Wavelength of an X-ray. Where? Oh, yeah. Yeah, it's actually 1 nanometer and below. Anything 1 nanometer and below. 0.01 nanometer and below is gamma rays, but 1 nanometer is fine, right? So let's try to figure out 1 nanometer wavelength বের করার জন্য কি voltage লাগবে. So Q is what? QV equals to hc by lambda. Q is the charge of electron, 1.6 into 10 to the power minus 19. V is the potential difference. We want to find that. Equals to h কত ছিল? 6 point minus 34, and C হচ্ছে 3 into 10 to the power 8 divided by lambda টা হচ্ছে, let's say 1 nanometer, okay, minus 9. একটু দেখবো কত voltage আসে. This will give you an idea of the voltage needed, and it typically isn't like a very small voltage. Okay, so try করে দেখো কত আসে. আজকে we'll work with this. Want to slow down after going through the plate because the plate is pulling the opposite direction of travel. Oh no, we also have the metal itself being positive, so it continues to travel. So there's no net field there, so it continues at the same velocity. 1.2 kilos. I want to something. Exactly 1200. 15 volts, right? Acha. So it's around. So that's approximately 1200 volts or 1.2 kilovolts. But here's the thing. We took 10 to the power minus 9, right? X-rays values can range from minus 8 to minus 13. And I think we talked about this. If you want high precision information, right? Do you want a longer wavelength or a shorter wavelength? Shorter wavelength. So shorter wavelength যদি হয় এটাকে কমাতে হবে, তার মানে ভোল্টেজকে কি করতে হবে? বাড়াতে হবে. And a typical X-ray machine can actually go up till 10,000 volts, depending on what kind of resolution you're looking for. Okay, so if you're trying to do an X-ray of a big object, তাহলে কিন্তু এত fine detail লাগে না. But if you're trying to do X-rays of very fine things, right? তখন এটা লাগে. So the voltage requirement is based on what do you want to do with your X-rays. Okay, right. So this is the X-ray waste release. একটা পয়েন্টে gamma ray বের হবে, অনেক হাই ভোল্টেজ লাগবে, অলমোস্ট 100,000 volts. Gamma ray হচ্ছে 10 to the power minus 15, মানে এই ভ্যালু থেকে into 10 to the power 4 মানে বেশি লাগবে. So that's 120,000. Okay, right. So let's move on. But before that, I have a question for you. Acha, by increasing the voltage, what can I increase? The energy of individual photon, right? But can you tell me what can I do here to increase the intensity of my X-ray? Intensity মানে হচ্ছে the number of waves per unit area. What can I do? increase the current. না মানে এখানে কি করতে পারি আমরা? I want to increase the intensity. Intensity মানে হচ্ছে the amount of photons that will be achieved over a particular area. How can I do that?
You can decrease the area of these razor.
Yes, I think I talked about this last class. So machine থাকে, so I can make the machine go where? Up or down, right? And if I can bring it very close to my target, তাহলে কি বেড়ে যাবে? Intensity. If I take it very far away, intensity কি হবে? কমে যাবে, right? So we can use that mechanism to vary intensity. Power change করলে তো voltage বাড়বে. Voltage বাড়লে হচ্ছে not necessarily more photons are released, just more energetic photons are released. Intensity is also a number of photons, right? Okay, this is what we did last class. আজকে আমরা X-ray wrap up করব. There are some challenging things here. ওগুলো একটু দেখবো, আচ্ছা? So number one হচ্ছে X-ray যে imaging করা হয় এটাকে কেমনে improve করা হয়, okay? So we talked about this last class, and if you remember that আমাদের হচ্ছে X-ray production এর হচ্ছে main trick was in the fact that different elements কি করে, different amounts of X-ray absorb করে. Bones absorb the most, right? That's why you have a white দেখা যায়. Tissues and muscles absorb slightly, তার জন্য একটু shadowy আসে, and rest of them don't absorb. তার জন্য the X-ray plane becomes dark because X-rays are falling everywhere. Some places you'll find that it's little ghostly একটা shape আসে. That's because some absorption is taking place, right? এখন আমাদের যেটা করতে হবে আজকে is learn the different ways to improve our X-ray imaging. Okay, so let me show you here individually. So আমি কিছু ইমেজ শো করবো তোমাদেরকে X-ray, তোমাদেরকে বলতে হবে what's wrong and how to improve it. Okay, so number one হচ্ছে এটা, and you get questions like this. Okay, so you have this X-ray that's been performed, and it's an X-ray of an arm, and the X-ray looks something like this. X-ray দেখতে হচ্ছে এরকম. So the bone is at the center, so it's easily visible like that. This is a finger, so the bone joints are here, and it's little like this. এরকম দেখতে. So the X-ray looks like that. Do you think it's a good X-ray? Why not? Yeah, because whatever in the side has absorbed a lot. কারণ ওই জায়গাগুলো সাদা হয়ে গেছে, right? Now এটা কি absorptionের জন্য হয়েছে নাকি হচ্ছে what's going on here? I'll show you another picture তাহলে তোমরা compare করতে easier হবে. A proper image of a bone X-ray, finger bone যেটা, would be like this. You can see the bone segments individually. In fact, you can see the joints there properly, and এরকম করে যেটা আসবে that. And you see maybe slight হচ্ছে এদিকে এদিকে কিছু থাকবে, because you can't stop the body from absorbing it, right? That's like a proper X-ray, you'd say. So can you tell me what's different about the two processes? Why is this one? This is not good, by the way. How would you describe this image compared to that? Like, can you tell me how is it different? Resolution. আচ্ছা একটা বলো. The surroundings have done it, right? Okay, now let's try to figure out why did this happen. Okay, so it's not to do with the absorption of X-rays. এই দুটা কিন্তু same X-ray setup করা হয়েছে, the intensity is same. Then why did this become like that? So এটাকে বলা হয়, what you're seeing here is typically referred as the shadow of an X-ray. এই shadowটা কেন form হয়? It's because the X-rays did not travel in a what line? Straight line. So the X-rays went left, right, সব দিক থেকে. So eventually যেটা হয়েছে, the absorption happened and they went this way, that way, সব দিকে spread হয়ে গেছে. And because of that, you have a very ghostly image out there. How and why did this happen? Because of X-rays going left and right? How can we fix this? But yeah, what was it? The collimator. So the collimator is this device that we've seen last class. It's this lead filter. A filter ভিতরে there are millions of what? Very small lines in them, and these lines that you see are all what to each other? Parallel. Having these parallel lines কি ensure করে যে তোমার হচ্ছে if there are X-rays out there, they'll only travel in what line before they reach the plate? straight line, right? So yeah, I'm dekhachhi, don't worry. So I'll show you a version of this. So yeah, the bone, the hand or finger bone and you have muscles and tissues around it. Typically what will happen, x-rays will bounce around. It's normal, it's a wave, reflection, refraction, সবই হয়, right? So wave taken আসবে, এদিক দিয়ে গিয়ে ওদিক দিয়ে বের হয়ে যেতে পারে কিছু, এদিক দিয়ে এসে হচ্ছে রিফ্র্যাক্ট করতেছে, ওদিকে চলে যাচ্ছে. So wouldn't the information or the waves start to go everywhere? And as they start to go everywhere in your image, right, your image becomes what? It becomes unclear, right? But if you have a collimator, what does the collimator ensure? The collimator only ensures the waves that are in what line to pass through. Straight line. And wouldn't that mean only the waves at that particular location can pass through, not waves from some other place? So this filtering process key ensure kore you only have waves that go in a straight line that hit the screen. Yes. No, that's the thing. So absorption এর জন্য হচ্ছে না because absorption যদি হতো তাহলে জিনিসটা হচ্ছে আর একটু different আসতো. I'll show you what happens. But এখানে কিন্তু it's a very blurry image. So the word they use is a shadow. So it looks like there's a shadow of something out there. Absorption hole, you can actually see the finger, outlined very clearly. That will be something different. Okay. So yeah, this is your collimator. So if you want to improve your clarity, what do? You use a collimator. That's a collimator kit. It's a LED filter. You place it above the plate that if waves will keep pass for it, straight pass for it. So yeah, having a collimator will improve your image like that. Let's look at the next one. It makes it much sharper. So typically a collimator will have do you remember diffraction gradient from so it's something like that, like a million lines in 1 centimeter. It's very precise, but diffraction gradients are made up of plastic. It's made up of lead. No, and not at all, because it's lead. It completely absorbs it. Okay. Even if it bounces at an angle, it gets absorbed within the lead before it goes out. X-rays block করার জন্য only lead possible, right? Any other dense material would be fine, but lead is like small amount. You can do this. Okay. Right, let's see another image. It's too interesting. It maybe guess করে পারবো না, but I'll try to show you. So somebody decided to do X-ray, and this is carefully, X-ray of the stomach. So stomach X-ray korte geche, not recommended. Why? Because stomacher মধ্যে there's actually no bony structure. So if you do the X-ray of a stomach, right, let's say কোলা, কিরকম দেখা যাবে? So you'll actually find like stomachটার হচ্ছে একটা basic idea পাওয়া যাবে এরকম দেখতে, but it's actually lost where amongst every other organ out there, right? So it'll be something like this. And kore, some people will do it if they have swallowed like a battery or something, or a bear kore, the spoon or something. You have seen X-rays like of a watch in a person's stomach or something. So oita jonno kore, but right now there's nothing inside, right? Because if you did have like a screw that the person ate, right? That's how it looks like, right? So anyways, that's not happening here. So the person did an X-ray of the abdomen. First question, why is it not very clear? Yeah, because there's nothing out there that can absorb the X-ray clearly, easily, right? Now, এটা করার সময় যেটা হয় এরকম কিছু জিনিস দেখা যায়. Yeah, so you can see your rib cage and other things out there. In some cases, you'll even see something like this. Yeah, picheta chole asche, right? So that's what happens. But I want to see the stomach. And now the reason why we do this and people do this, okay, is because there's something that happens in the stomach. It's called an ulcer. An ulcer যেটা হয় তোমার স্টমাকে যে লাইনিংটা থাকে ওটা হচ্ছে ছিঁড়ে যায়. It's basically your stomach has a hole in it. And এটা হয় because of acid and a lot of other things out there. I don't know if you know this, your stomach has this very high acidic acid in it. It's so acidic, right? It's supposed to actually tear a hole in your stomach instantly. But beneath that, there's this mucus layer. Where mucus ta ki kore acid take a block kore rakhe. Sometimes the mucus layer goes away, and what does the acid start to do? Make a hole. And it's like the worst thing that ever happens. So now you want to know this. Unfortunately, CT scan eta dekha jay na, because it's still a muscle. So if there's a tear in the muscle, you wouldn't really see it. X-ray to dekha jacche na. Ultrasonography to absolutely dekha jabe na, because it's just a shadow of the organ's boundary. You'll see the outside of the stomach, right? So how do you find this? So there's a process out there. It's called endoscopy. where they take like a pipe and they put it into your stomach, and with the camera they actually have to see it, right? So that's one way out there. It's actually the better way. But back in the day, endoscopy, adventure age, or endoscopy, they use cameras. They used to use optic fiber, if you remember from your O levels, right? That was like the most horrible procedure out there. So যেটা ছিল, they had another way. ওইটা কি করতো, and you probably will hear people doing this. They'll make you drink, right, a liquid before the X-ray. It's called barium milk. Barium is a very high proton number liquid, like, substance. But barium milk, right, যেটা হচ্ছে একটা barium sulfate, it's actually nothing. It doesn't do anything to your body. It's fully inert. It doesn't react, does nothing, right? You drink it. And as you start to drink it, what it does, it goes through your food pipe, goes into your stomach, right? And in the stomach, it creates a what? Lining. And because it's very dense, right, it creates a very sharp, clear image of the lining. So you're lining দেখতে পারবা কেন? Because it wraps around the inner layer of the stomach like that. And if you have, let's say, an ulcer or something, you'll start to notice that. Okay, so the barium milk starts to wash out of your stomach, seep out of your stomach, and that tells you like you have an ulcer. Do you get my point? So এটার নাম, এটা আমি এখন কেউ ইউজ করে না, বাট এটা তোমাদের সিলেবাসে দেখা করাচ্ছি. There's a name for this. This is called contrast medium. So contrast medium হচ্ছে when you don't have good contrasting things inside your body, like bones and muscles নাই. You can actually create a contrasting medium by applying a layer of something. Now, this thing is now done at every CT scan. So if you ever do a CT scan, they'll put like a liquid into your blood. And that liquid they put into your blood is actually a barium liquid, dye, or like a dye, DYE. And it goes through every vein in your body. And when you do a CT scan of the body, it starts to show your what as well? Veins and tissues and everything. Data normally X-ray আসার কথা না, আজকে CT scan করবো. CT scan is actually X-rays. Okay, so yeah, the contrast medium is there in your syllabus. I've given notes of everything, so don't worry about that. But just বুঝে নাও that it's a thing that a person takes in to create a contrast so that that particular thing shows up very clearly. Rest of them don't show up. So that's called a contrast medium. So yeah, the two things that we have here at a contrast medium are tomar collimator used. The third one, the last one, is this one, which is let's say you're doing your X-rays, right? And the X-rays turn out to be like this. So তোমরা একটা নিজের টেস্ট করতে পারবে, আচ্ছা? So you have done an X-ray, and the X-ray image looks like this. এরকম দেখতে, and it's like this, where you can see the outline of your finger. You can even, in some cases, see what passes over it, the veins, blood vessels, right? এরকম দেখা যাচ্ছে, এরকম একটা X-ray আসলো. Is this good or bad? Why? Yes, it means if you're seeing your blood vessel, if you're seeing your tissues and muscles, they must have what? The X-ray, absorbed X-ray, right? And every time your tissues and muscles absorb the X-ray, right, they experience ionization. Ionization is a process where the structure of your cell degenerates. So the nucleus থাকে একটা ভিতরে, there are DNA structures in them, which are basically protein structures. Once the X-ray passes through it, it changes the structure. Two things can happen, and this is O-level review. One is the DNA strands je thake, combination, right, can alter. That's called mutation. And the other one is the DNA strands break down entirely. That's called degeneration or destruction. Degeneration hole kono problem nai. Our body can make up to 1 trillion cells every second. They'll just come and do new cells, no problem, right? But যদি হচ্ছে strandটা change হয়ে যায়, the body doesn't know, like it doesn't see it as a problem. But strand change হওয়া যাওয়া মানে কি? That the cell right now has a different function. Cellular function is controlled by the nucleus. The DNA basically tells it like what cell does what, right? যখন এটা change হয়ে যাচ্ছে, what's happening is that the cell is still intact, but its purpose is now what? Different, which is not a good thing. Why? Tomar a finger, muscles, tissues, J cell below, they're supposed to do one very particular thing. Otar মাজখানে যদি আরেকটা cell starts to grow differently, right, that will start to what? Your finger movement, inhibit it. তখন কি হবে? এখানে একটা tumor form হওয়া start হবে if it has a very high growth rate. So growth rate থাকে basically cancer, right? Cancer হচ্ছে cancer is basically unwanted growth of cells, right? Now there's like 101 different permutation combination out there. Sometimes you'll find that the cells are growing way out of control. That is when it's a problem. Why? Because they'll grow so fast, they'll actually start to take up the space of what? Healthy finger cells. And the finger cells and tissues and muscles have to do a very particular job, right? And that's the problem that you'll have when you have like a cancer, right? So X-rays a problem ta hoy. So what was the main issue here? We allowed a lot of what to happen? Absorption. Can you tell me what is the reason why the cells and the tissues absorbed your X-rays? Was it because they were too energetic, or was it because they were too weak? Exactly. So when your X-rays are very weak, right, as they're traveling through, they sometimes can't even make their way through tissues and muscle. And that means they're being absorbed by the body, which is the worst thing that can happen. So on the X-rays, you know, the number one thing that the person, the radiologist, the person who does the X-ray has to set is the right intensity. The right intensity that allows you to what? Make sure you get a proper image, but also make sure absorption is the most least possible out there. It can be controlled by moving it up and down, and also by controlling the voltage and the energy of your wave, but mainly by moving it which way, up and down. So if you bring it down very close, but close unlike key problem. I want to do an X-ray of the whole abdomen, but the chest. For pneumonia, they do this, right? So it to কাছে হলে তো চেস্টের পুরো ইমেজ আসবে না, দূরে নিতে হবে। দূরে নিলে আবার হচ্ছে বেশি দূরে চলে গেলে the X-rays will become what, too weak. তখন they will be absorbed by your body. So eventually there's like a very sweet spot that you need to figure out. Typically radiologists যারা হচ্ছে technician, the people who work like perform the X-ray, right? ওরা হচ্ছে they have like a book. ওই বইয়ের মধ্যে just লেখা থাকে যে for this setting, for that setting, right? So ওটা করলে it's fine. Nowadays you can do like a 6-month course and just start doing radiology, right? But the thing is that it's actually much more complicated than that. And the fact that you shouldn't do it many times, right? It was 6 months course a night, because no one cares. So the problem is that you shouldn't do X-ray that often. It increases the risk exponentially. Okay, right. So that's your X-rays. Any question? Any clarification? So I mean, typically cancer, right, comes from like 6-7 different sources. One of them is radiation mutation, but mostly commonly jegula cancer এখন হয়, right, these are all from the chemicals you consume. Like for example, plastic cups jegula, you take a plastic cup, you put it in a microwave oven, you heat the microwave oven on, ওই plastic থেকে একটা element বের হয়, ওই এলিমেন্টটা তোমার ড্রিঙ্কে চলে গেল, that has more higher chance of giving you cancer than X-rays. But we microwave every plastic out there, right? So it's really bad. BPA আর অনেক কিছু থাকে এটার মধ্যে, which basically tells your body to go out of control. It disrupts everything. Okay. What microwave plastics? Of course. But I didn't drink. I gave it to people. Right. So all of them. Also, so when you microwave food, right, Tupperware থাকে, এগুলা থাকে, ওগুলা থাকে, এগুলা কোনোটাই না. You're supposed to put them on a like a glass container. Glass is the best. আচ্ছা, গ্লাসে কোনো প্রবলেম নাই. The lead that we used to stop electrons. Oh, right. Yeah, it does the same thing here, but these are waves of X-rays. Those are electrons. You can slow down electrons, but yeah, but the X-rays are not slowing down. They're just blocked. So there's no break-in radiation this way. There's only break-in radiation that way. Could you explain the hardness? Yeah, so I'll now go through the notes and explain what hardness and everything is means. Okay, shall I screen it too? So let's try to understand everything that I've just mentioned, but in technical terms that your syllabus wants you to know, okay? So what's hardness and intensity? Shall I to know? These are real terms. When I mean, it's like so that you get an idea, but how do you use the words, right? So the bone becomes very prominent and the rest of them are not there, right? It makes your image very hard. Soft image কিরকম লিখতে হবে? soft image would be very like hazy, heavy, blurred, right? So if your camera is out of focus, that produces a sharp image or a soft image. Soft, right? Hardness is basically sharpness. Okay, so intensity represents a number of waves generated by a power source. An intense source is needed to generate a clear image. This can be increased by increasing the power of the filament. So filament power, more electrons can be released. More electrons মানে more X-rays. That's more intense, right? তারপর হচ্ছে এই part হচ্ছে hardness represents the ability of the X-ray to penetrate the target. This depends on the energy of the photons that can be increased by increasing the accelerating voltage. Soft X-rays are bad for diagnosis as they lead to more absorption, and this can lead to ionization and cancerous growth. So if your X-ray image is soft, right, it's a problem. So if you ever do an X-ray and you see it's very hazy, it's one of two things, by the way. Actually, they use a wrong setting. What's the other one? No. No. Collimator হচ্ছে could be a thing. Let's say exclamation ঠিক আছে, problem নাই. What's the issue? So no, the answer is yes, very good. You moved. So X-ray সময় হচ্ছে you're supposed to stand very still, right? Some people just panic or morning movement করে. It's something that happens, right? So let's say you're trying to do a chest X-ray, you have to stop your breathing. Some people just can't, or they stop the breathing. যখনই ছবি নেবে তখন ছেড়ে দেয়, because ওরা ভিতর থেকে বলে যে এখন ছাড়েন, but what happens, there's a lag, and then they press the button and it didn't actually take the picture yet. So issues happen. And the worst thing is that ওটা তখন ওরা দেখতে পারে স্ক্রিনে the X-ray, right? And it's very blurry. So আবার করেন চলে, and then they'll do like 4 or 5 within like an hour, where you're supposed to do once or twice maximum in 6 months, right? So yeah. ওরা এটা করে because doctor will say যে কোথা থেকে করে আনছেন, এটা কি কিছু দেখা যাচ্ছে না, so ওরা হচ্ছে just করতে থেকে until they get a sharp image. Okay. Yeah. So water has little different density than the muscles and the tissue. So when you do X-ray, like pneumonia causes water buildup in the lungs, right? The water creates like a shadow. So it appears a little dark because the X-rays are going through the water more easily than rest of the body, because water is H2O, and then muscles and tissues and bones are CHONS, a lot of heavy elements out there. So it produces like a shadow out there. So it gives you an idea that there's some water buildup out there, and then you do CT scan to know the exact amount. Okay. The water buildup for lungs. I was curious because back when COVID was going on, right, they made people do X-rays like every time. Every time you go, they'll just ask you to do X-rays, because if you have pneumonia, it gets very bad, right? So some people did like 4 or 5 times in a week because they were getting worse, right? Then I looked online, and apparently right now, right, there are X-ray machines where they have set certain settings that you can bring it down to a very safe level. So you can actually do multiple times out there. Given that those X-ray machines are not available in Bangladesh. So because I looked up, these are very high-end German Siemens company থেকে বানায়. It's like a very expensive setup. যেগুলো local থেকে বাংলাদেশে, they do one of two things. They either buy second hand, or it's like really old. So the really old ones are like you have no control over the amount of exposure. The new ones are very safe. Right, let's move on. So ways to improve your X-ray imaging. So reduce the dose or reduce the absorption of the X-rays. If the X-rays are low intensity, then it can be easily absorbed by the tissues and muscles, and this can lead to ionization, as we mentioned. Intensity can be increased in many ways. One of them is to make your photons more energetic, or what can you do? You can bring it closer. Arta jinish use korora, an intensifier. It's basically they take the X-rays, right, and they concentrate it to a small point. So therefore, সবগুলো এভাবে না বের হয়ে, they basically come out from a smaller range out there. So this is also made up of lead. আর হচ্ছে sharpness. Sharpness হচ্ছে যে তোমাদেরকে একটু আগে বলছিলাম, to improve sharpness, we decrease the spread of the X-rays. এটার জন্য কি ইউজ করা হয়? Collimator. Sharpness improve করে. And contrast is what? The distinction between the darks and the lights in your images. To improve contrast, we use a fine lead collimating, which I have to say anything. Right, contrast contrast জন্য collimator use করা হয়, but একটা correction করে নিই এখানে, there's barium milk এটা কোথায়? Right. Right, so let me show you what the contrast part is. Can you tell me which one is a more contrasting image? Mane, the darks are darker, the brights are brighter. Yeah, eta, right? And we achieve this using what? Collimator. So collimator can improve your contrast. But এখানে, for example, collimator দিয়েও কিছু হতো না। এখানে how did you improve contrast? Yeah, by introducing a separate thing into your body, the barium milk. Okay, so there are two ways of improving contrast. একটা হচ্ছে you can use a collimator. The other one is you can use a barium milk or something that has a high proton number to improve the contrast. Yes. The energy of the photons, because HF QV equals to HC by lambda, right? So আমি যদি QV টা বাড়াই দেই, ওই QV টা কিসের energy? Photoner energy. So if I use high voltage, my photons will be more energetic. That's how we do it. Increase intensity, but not the energy. No, the bones will block X-rays. It's just now if you have very high energy photons that can go through your bones, you're talking about gamma rays. So gamma rays can go through your bones. The X-ray stops at the bones.
We use gamma rays for the
Yeah, we do. It's called a gamma camera. It does the same thing as an X-ray. Why?
Why do we use gamma?
It's very short bursts. Ionizing ability is low. If you remember from your O levels, alpha, beta, gamma ionization is pretty low, right? So it has same problems as X-rays, but it gives you a much more clearer image. So it's not like better than X-rays. It's an alternate to X-rays. Okay. আচ্ছা, এখন হচ্ছে I will show you the math, but before that CT scan একটু দেখে রাখি। So math এখানে কি আসছে আমি একটু বলে রাখি, তোমরা math করে আসছো already. Mathটা হচ্ছে I have X-rays passing through my bones here, let's say. Not bones, your body. You need to find out the amount of X-ray that makes through the body. So এটা হচ্ছে, tell me what to do, acha. So you have your bone here and you have your X-ray coming in from here, and X-ray the body enter করলে it goes through muscle, it goes through bone, it then goes through your muscle again, and then it reaches the bottom, right? বোনের ভিতর দিয়ে যদি যেতে পারে তাহলে obviously নিচে কিছু একটা পাওয়া, নাহলে দেখো খুবই কম হয়ে গেছে. How do you find these values? Do you remember? No. So X-rays don't reflect. They will only go forward because they're very penetrative. Yes. Yes, what was it? Last class করছি, মনে রাখতে পারলে কিন্তু problem. Yes, I equals to I naught e to the power minus mu x. এটাকে হচ্ছে attenuation equation বলা হয়, but basically we says the absorption amount, right? So when you have X-rays coming in here, the amount of X-rays that can actually pass through depends on what? এগুলার হচ্ছে mu values. So mu for muscle, mu for bone, mu for muscle, ওটা করে এখানে নোটিস করবা as it goes through here, the change is very limited, and because it's very limited, it means that nothing is absorbed, and most of it কোথায় reach করে on the bottom. So the bottom becomes what? Darkened. But এখানে notice করবা the amount that is absorbed is what? Very high. So by the time it reaches here, it's almost nothing. So therefore bones গুলো সব block করে দিচ্ছে. That's how we know this. Okay, so this math does exist here. I'll come back to this math later on, but আজকে একটা জিনিস start করতে যাচ্ছি, ওটা করে নেই. 10 minutes হয়ে যাবে actually. So that is CT scan. Okay, so CT scan টা করি আমরা. So what does CT scan stand for? মানে CT যেটা, so it's actually called coaxial tomography scan, commonly known as the CT scan. Acha? Yeah, so coaxial tomography. These words have very straightforward meaning. Coaxial means from every direction. Axis, axial, so you're taking information from all direction. Tomography is mapping. So it's basically mapping your body from which side, every side, right? Now, this process is quite interesting. Process কেমনে কাজ করে দেখাই তোমাদেরকে। So সবাই একটু স্ক্রিনে দেখো। So imagine you have a structure that looks like this. আমি স্ট্রাকচারটা ড্র করে নিয়ে আগে। 3D structure. So coaxial tomography was a theory for a very long time. Computers couldn't process it. তার জন্য করা যেত না। Now that computers are capable of doing this, that's why CT scan has become more accessible for us. So the way it's done is something like this. Let's say this is a structure out there. It's a 3D structure, and you are in a dark room with this 3D structure. You need to figure out the 3D structure without touching it. So 3D structure to তোমার সামনে রাখা, and it's a dark room, right? And the structure is out there. You can't touch and feel it, but you need to figure out the shape of it. You have a torchlight with you. Okay, that's it. How can you find out the shape of this? So the thing is, you can't, if you beam light on it, you can't see the shape. You can only beam light from sides, not like, just see the torchlight and see what it is, right? So you can only beam light from the 3 axis, x-axis, y-axis, and z-axis, right? So how would you figure out the shape of this object? What would you do? Yes. So কি করবে এখান থেকে, you'll take your light and you'll beam your light like that. And as you beam your light like that, background এর মধ্যে, right, যেখানে হচ্ছে তোমার লাইটটা পড়বে, ওইখানে একটা শেপ দেখবা। কি শেপ দেখবে এখন বলতে পারবা? The 2D shape, very good. The front shape like that. So now you have an idea that one side of this object looks like that. Do you agree? Okay, next কি করব, we'll send our light from this side. As we send our light from this side, এখানে যখন লাইটটা পিছনে পড়বে, you'll get an idea of what this looks like. কিরকম দেখতে হবে? What do you think? Yeah, it'll be just a rectangle like that, right? So turns out আমি যদি আর একটু ডিটেইল অ্যাড করি এখানে, let's say নিচ দিয়ে ভাঙা এটা এরকম, okay, so like that part is cut off. তাহলে এখানে কি নোটিস করবা? দেখবা যে নিচের জায়গাটা হচ্ছে এরকম দেখতে, sorry, like this. এই যে এই পার্টটা খালি দেখা যাবে। Do you agree? Right. So turns out যে এরকম করে 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 eventually if you do it from all the sides, you will get the information of what the shape is. বুঝছো জিনিসটা? This is called coaxial tomography. It's used in mapping এ ইউজ করা হয়, 3D structures কে recognize করার জন্য এটা ইউজ করা হয়. We use this exact principle for the human body in CT scan. কেমনে করি আমরা? So let's say you want to do the CT scan of like an organ, right? So let's say the arm. So arm-এর CT scan করতে চাচ্ছ তুমি এখন। কেন CT scan করবো instead of X-ray আমি বুঝাচ্ছি in a minute, but আমরা যেটা করবো, we'll take the person's arm and we'll place it in a machine. The CT scanner যে মেশিনটা থাকে, it's like a very big circular disc-এর মতন থাকে এরকম, and ওটার মাঝখানে the patient actually has to move in. So এখানে একটা হোল থাকে, and এটার ভিতরে হচ্ছে তোমাকে এন্টার করতে হয়. Has anyone done a CT scan? No. Seen a CT scan? আচ্ছা না, আচ্ছা fine. No, ওটা MRI. Music বাজে? হ্যাঁ, have you done that? So by the way, musicটা কিন্তু হচ্ছে ওই হসপিটালের চয়েস। মানে some places music হয় না, some places হচ্ছে হলো random হচ্ছে হলো গান হয়, সাউন্ড হয়, and some places একটা পার্সন কথা বলতে থাকে continuously যে রিল্যাক্স করেন ওরেন এইসব বলতে থাকে. So yeah, it's basically a recording that you can play. What I've heard is like if you go in some places they allow you to play your music. It's a USB ওইখানে বলবো যে এটা প্লে করেন, because some CT scans take 2 hours. So you have to go into this machine, right? And people who are claustrophobic, right? They have to be put into sleep before they go in this because সম্ভব না. So they'll put you in this machine and it's like this close to you, and there's like this wheel-like thing continuously going around you, right? Some people just get scared, right? So এখানে যেটা করা হয়, they put your arm here if you're doing a CT scan, but here's the thing, যদি CT scan arm-এর করো, you still have to put your whole body in. মানে you basically lie down here. আচ্ছা, then what happens? So যেটা করে এখানে there's this very fast moving, carefully দেখো, there's a fast moving segment here which is beaming what at your arm, X-rays, and on the other side, exactly opposite side, there is a component that is what the X-ray, receiving the X-ray. So basically ওরা যেটা করে এখানে, they keep sending X-rays from which direction? every direction. So এভাবে send করতেছে, এভাবে send করতেছে, and it's been done at a very high rate out there. By doing that, the computer picks up information of every side. দেখছো যে আমি কিরকম করে করলাম? Now imagine instead of doing 6 sides, they do 360 degrees. When they're sending light from which angle? Every single angle imaginable, right? And it produces insane amounts of data. A few 100 GB data in few seconds. আগে computers এটা process করতে পারতো না. It would take weeks for the CT scan result to show up because computer এটা render করে. এখন it takes 10 seconds. Within 10 seconds কি পাবা তুমি? This part is very fascinating. Within 10 seconds you'll get your hand sliced up. So কি করবে ওরা তোমাকে এরকম করে in the computer you'll find that there's an option where you can actually see what of your arm, slices of your arm. So যে মাঝখানে বোন দেখতে পারতেছো, and that's the muscles and tissues out there. You can literally use the mouse, zoom into every part of your body and see it individually. It's like you can take a walk through the arm and the tissues and the muscles because you have a what structure in front of you now, a 3D structure, and you can open slices. Let's say 3 centimeter in it, you want to see what's happening, right? You go there, there's a scroll করে কমাবা, নিচের দিকে দেখবা একটা করে লেয়ার উঠে যাচ্ছে, উঠে 3 centimeter পার্টটা just sliced out comes in front of you. Why? This 3D image that you find, right, is actually not a 3D image. It's about 1 million what images put together, 2D images put together, and that creates the 3D structure that you have. And it is one of the most I would say comprehensive tests out there, but it takes time. মানে এতগুলো ইমেজ নিয়ে 3D create করতে টাইম লাগে. CT scan solves most of the problems that you have, except for your brain জন্য we have to go for MRI because MRI টা হচ্ছে safer. বলো? It is not full. It is X-rays. So CT scan is basically using X-rays to do 3D, right? So obviously it's yes. CT scan is same rule as X-rays. Oh no, so they do small doses over a very large time. So it's not like X-ray where a large dose in a small time. This calculator, it's just because of the color. They haven't seen this, so they don't allow this. You can paint it a different color, they'll allow it. Yeah. What you can do is take it with you to the exam, but keep a backup.